You want or need to memorize the cosine and sine of the special angles in the unit circle. The best advice I can give you to accomplish that is not to memorize it. It's to understand the unit circle and its layout. So we'll need to familiarize ourselves with a few things in order to gain that understanding. I'm going to make a list of things that we need to get familiar with. Some of them you might be familiar with already, other ones you won't, but we'll go over each one, so don't worry about it if you're not entirely familiar with everything. So we have the unit circle. Angles. And how they're laid out in the unit circle. The fact that the xy coordinate of where the terminal side of the angle intersects the unit circle is equal to cosine theta sine theta. The special angles, I'll just use an abbreviation for angle, and the values. Those are the values that the cosine and sine of the special angles can be. So first, the unit circle. I'll draw a unit circle on the rectangular coordinate axis system. That's one we're familiar with. It's also known as the Cartesian plane. So we have an x-axis, and we have a y-axis, and we have a circle. Now what makes this a unit circle is that it's a circle of radius 1. So the radius is 1. And now for how angles are laid out in the unit circle. Switch to red for this. Angles have an initial side and a terminal side in the unit circle. If an angle is a position angle, and 99% of the angles that we deal with in the unit circle are position angles, the initial side will be the positive x-axis. So here's the initial side of our angle. And here's the terminal side of the angle. I'm going to make this a 45-degree angle. So that's 45 degrees. So you know that every point on the Cartesian plane or the rectangular coordinate axis system has an x and a y coordinate. That xy coordinate is its address. So that's a unique address for every point on the rectangular coordinate axis system. So this point right here, the point where the terminal side of the angle intersects the unit circle, that point has the coordinates cosine 45, sine 45. So that's the coordinates of this point. And we would like to know, since 45 degrees is one of the special angles, we would like to know what the cosine of 45 and the sine of 45 is. That's one of the things we're trying to memorize. And I'm saying, if you understand this discussion, you won't need to memorize it. You'll just understand it and you'll be able to figure it out no matter what special angle is given. So let's talk about the special angles. The special angles starting at 0, 0 is one of the special angles. That's right here. That's where the initial side and the terminal side are. So the angle 0, there's no angle. The angle hasn't moved anywhere. So the initial side of the angle and the terminal side of the angle lie on top of each other. So, but that dot that I put there is the place where the terminal side of the angle intersects the unit circle. And then we have the next one is 30 degrees. And I'm not going to draw the terminal sides. I'm only going to draw the dots where the terminal sides would intersect the unit circle, because the picture is going to get all convoluted with too much stuff in it to follow the discussion. So I think it'll be easier this way. So 30 degrees would be right here. We have 45 degrees, 60 degrees is here, and then we have 90 degrees. And I'm only going to do the first quadrant because this just repeats all the way around. So, but I guess I will say that this is 90 degrees. Straight line would be 180 degrees. This is 270 degrees. And here we have 0 degrees, or 360 degrees. Same thing. 0 degrees is not moving around at all, and 360 degrees is all the way around, and the terminal side still lies on top of the initial side of the angle. So, what did I say? I said 30, 45, 60, 90. So the way to think about it is that every quadrant that kind of just repeats. So you go 30, and then 30 plus 15 is 45, plus 15 is 60, plus 30 is 90. So I'll write these in. 30 degrees, 60 degrees, and 90 degrees. That's going to repeat from any axis. So over here in the second quadrant, the special angles are going to be, well, that's going to be 90 plus 30, so it would be 120. And then 120 plus 15 is 135. 135 plus 15 is 150. And 150 plus 30 is 180. So that just keeps going around. And those are all the special angles. So you should be able to lay out the special angles or think it through in your head, that picture in your head. You should be able to do that with a small amount of practice. So let's think about the coordinates of this point. Let's not think about the coordinates of this point. So now let's think about the values of these special angles. So those values are in order from smallest to largest. We have 0 is less than 1/2, is less than root 2 over 2, is less than root 3 over 2, is less than 1. So the cosine and sine of all of these angles, all the way around, are going to be one of these 5 values. Over here in the second, third, and fourth quadrant, it could be the negative of those values, but we'll get into that, and that'll be easy for us to decipher which one should be positive or negative. So the coordinates of this point right here, well, that point is on the x-axis. So the coordinates of that point, since it's the unit circle and this circle has a radius of 1, the coordinates must be 1, 0. And then, so the x-coordinate here is 1. Well, the x-coordinate here, the x-coordinate is just the distance from the y-axis. So the x-coordinate here is going to be this length, and the x-coordinate here is going to be this length, and the x-coordinate here is going to be this length, and the x-coordinate here is going to be 0 because it's on the y-axis. On the y-axis, the x-coordinate on the y-axis is 0. Anywhere on the y-axis, the x-coordinate is 0. And the y-coordinate will be the distance from the x-axis. So the y-coordinate here is, well, we're on the x-axis, so the y-coordinate is 0. And the y-coordinate here will be this length. The y-coordinate here is this length. And the y-coordinate here is this length. The y-coordinate here is that length. That's going to be, the y-coordinate's obviously going to be 1 because we're on the unit circle and we're on the y-axis. So the unit circle is a radius, has a radius of 1. So the y-coordinate there is 1. So let's think about what the x and y coordinate are for 30 degrees. So for 30 degrees, it has to be, the x coordinate has to be one of these 5 values. Well, there are 5 points in this quadrant that the x coordinate is going to be. And it has to be one of these 5 values. So here's 1. 1 is the biggest. That corresponds to the longest, the biggest distance from the y-axis. Well, right here it's going to be, it's the second biggest distance from the y-axis. So it must be root 3 over 2. And the y-coordinate, by the same reasoning, the y-coordinate here at this point was 0. So this is going to be the second shortest distance. The second shortest will be this one, 1/2. And that's the x and y coordinates of that point right there. And that's the cosine of 30 degrees and the sine of 30 degrees. So that's basically it. That's pretty much the entire unit circle, or the cosine and sine of the special angles of the unit circle. So with that information, you should be able to tell me what the cosine and sine of, say, 240 degrees is. So you want to think this through in your head each time. You don't really have to draw it out, or maybe the first few times it's a good idea to draw it out, but after a while, after a short amount of time, working with it maybe 5 times, you'll be able to think it through in your head every single time. So I said 240 degrees. So let's think, where is 240 degrees on the unit circle? Well, here's 270, and the way we find the special angles is each one from the axis, it's going to be 30 degrees. So 270 minus 30 degrees is 240 degrees. So that's it, 240 degrees is right there. And if we mapped out the other ones, the other special angles in this quadrant, just for the sake of illustration, because we're just getting familiar with this right now, we would subtract 15 from that, and that would be right here, and that would be 225 degrees. Then we'd subtract another 15 from that, and that would be 210 degrees. And we subtract 30, and we get 180. So that kind of maps it out and says, okay, we did it right. Because if we subtract 30 from 210, we get 180. So that looks good. So the cosine and sine of this angle, 240 degrees, that's this angle right here, 240 degrees, well, it's going to be, the cosine is going to be that length, and the sine is going to be that length. So cosine, well, we're not on the y-axis, but we're very close to the y-axis. So that's going to be it's not going to be 0, it's going to be the second one. It's going to be 1/2. But we recognize that we're to the left of the y-axis, and x is negative when we're to the left of the y-axis. So it's going to be negative 1/2. And as for sine we associate with the y-coordinate. So the y-coordinate here, well, the y-coordinate here is -1. So the y-coordinate here is going to be the next one, the next biggest one. It's going to be √3/2. Or that length is √3/2. But the y-coordinate there is going to be negative √3/2. And that's the cosine and sine of 240 degrees. -1/2, negative √3/2. So let's try one more. So let's do this angle. It's right in between the two. So that should be, let's see, right in between. It should be 360 minus 30 is 330. 330 minus 15 is 315. So it's 315 degrees. And again, just for the sake of argument and for illustrative purposes, we'll put in the other special angles. Because until you get used to it, I think you really want to make sure you're doing it right. Once you get used to it, you'll be completely confident and you'll know you're doing it right. So let's see, 270 plus 30 is 300. And then we get 300 plus 15 is 315. And then 315 plus 15 is 330. And then 330 plus 30 is 360. Yep, so we got it. We got it right. So this is going to be, let's see, the x-coordinate is going to be this length. And the smallest one is right here on the y-axis. The next smallest one is here. And the next smallest one is the one we want. So smallest, next, oh, must be √2/2. Using the same line of reasoning for the y-coordinate, we're going to start here, and we have the smallest is 0. The next smallest is 1/2. That distance is 1/2, but the y-coordinate is negative 1/2. And the next smallest is root 2 over 2. But it's the distance is root 2 over 2, but the y-coordinate is negative root 2 over 2. And there we have the cosine and sine of 315 degrees. Cosine of 315 is root 2 over 2, and the sine of 315 is negative root 2 over 2. So if you like that explanation and you'd like to find out more about math and the services that I provide, my website is expertmathtutor.net. So please feel free to check it out, and feel free to comment on my explanation here. And if you have any comments about how I can make it better, or use different colors, or maybe it might be a little bit small, or anything you want to comment, that would be much appreciated. And hopefully I will hear from you. Thank you.